We have discussed the process of electrolysis, some applications and uses of electrolysis. Now let us look at a law that governs how a substance can be deposited on the electrode or how gases can be released as electricity passes through a solution in electrolysis. In this lesson, we shall talk about Faraday's first law of electrolysis and look at the second law in a subsequent lesson. At the end of this lesson, you should be able to state this law and derive a mathematical expression for it. Michael Faraday, who was an English scientist, discovered that during the process of electrolysis, the mass of a substance that is deposited on an electrode is proportional to the quantity of electric current that flows through the solution. Let us use a simple electrolytic process to describe this relationship. If we dissolve a metal carbonate like calcium carbonate in a solvent like water, the calcium carbonate will dissolve to form calcium cations and carbonate anions, which will flow freely in the solution. When a direct current is passed through this solution, electrons will flow from the negative terminal of the battery to the cathode and into the solution, while electrons will flow from the solution through the anode to the positive terminal of the battery, and this will complete the circuit. But what happens in the solution? Let us take a closer look at the process in the liquid. The calcium cations have lost 2 electrons, which were donated to the carbonate anions. So we can say the calcium cations have a charge of +2. The electrons coming into the solution will attract the positive cations, which will accept 2 electrons from the cathode and become neutral calcium atoms and be attached to the cathode. On the other side, the carbonates, which have accepted 2 electrons from the calcium cations, will have a -2 charge. They will be attracted to the positively charged anode, where they will give the excess 2 electrons they earlier accepted from the calcium cations. This process leads to a flow of electrons in the solution that completes the circuit. We can then say that for every pair of electrons that enter the cathode from the battery, 1 calcium atom will be attached to the cathode. If we allow this process to continue for some time, and we record the time as T, then some amount of calcium would have been deposited on the cathode. If the mass of the calcium deposited on the cathode is m, and the current that has passed through the solution is I, then we can say the mass of the calcium deposited is directly proportional to the current and the time it took the current to flow. Mathematically, we can say m is directly proportional to I multiplied by T. But the current I is equal to the quantity of charge flowing at a given time T. This implies the quantity of charge Q is equal to I multiplied by T. We can then write our relation as M is directly proportional to Q. This relationship is Faraday's first law of electrolysis. It states that the mass of a substance deposited on an electrode during electrolysis is directly proportional to the quantity of charge that passed through the solution. To remove the proportionality sign, we must add a constant. This constant is represented by capital letter Z and is known as the electrochemical equivalent. This varies for every element, and it is the mass of an element that is transported to an electrode by 1 coulomb of charge, often measured in grams per coulomb. And there you have Faraday's first law of electrolysis. Keep learning.